that models are converted into STL file format, so that the projects which they have generated in as an ideological background, which will be taken to slicing software. The slicing software is nothing but based on some printer, it will have specific softwares, like we have chick to box, we have slicer, we have cura, and we have repeater host. We have four softwares, ma'am, for four individual 3D printers. For four individual 3D printers, we have four softwares. So these softwares will be helpful for finding the size and shape of the 3D printer, which has been modeled. So the slicer is a toolpath generation software used for the majority of 3D printing process for the conversion of 3D object model to specific instructions for printers. Like these are the specific instructions which we will give: infill, supports, raft, speeds, and layers, colors, etc. So what is an infill? Infill is nothing but the intermediate fillings. Infill is like we can give in terms of percentage how much it's need to fill: 0 or 100. If 0, there will be no infill. There will be vacant space in between. If we have mentioned it as 100, then the infill will be completely filled. So based on the requirement, we can give the infill. The next one is support. If the model have an overview or overhanging part, if it is hanging, then it definitely need a support. For that purpose, we can give some supporting elements, like uh, supporting pillars, supporting columns, and so on. Based on the size, we can change it in our slicing software based on the size and shapes. The next one is raft, ma'am. In this raft, what we are going to do is this is completely for our printer to be removed from the printer bed. We can't able to remove the object from the bed. So for that purpose, we are going for raft. So easy detachment purpose only, we are going for raft. So what are the types of raft? I'm going to give you a small explanation for that. So the adhesion take place by means of skirt, brim, and raft. So skirt is nothing but if we are going to start our object, so there will be no primary heat heat conducted on that particular filament. So that filament is not properly fused to make an object. So initial stage of the process will not be clearly apparent. So what we are going to do is we will be making a skirt. It will give a outermost layer. It will give you the outermost layer for our entire object. After that, if after that our project will be, after that the 3D printer, the G code will generate the 3D printer models. The second one is brim. Brim in term helps you to create a background layer or ground layer, and the ground layer itself completely make a solid structure. If we remove the brim, then easily we can able to separate the object. So object will be beneath the brim. The next one is raft. Raft is completely a detailed structure, the raft is having a more than 5 to 6 permanent layers. It will never allow the object to touch the ground. So the object will never touch the ground, so we can easily detach it from the addition bit. The next one is a layer wise assembly. After the slicing is over, it is taken to layer wise assembly software. Nowadays the slicing software itself, it is doing the same job, layer wise assembly. So the layer wise, from y is equal to 0, y is equal to 1, y is equal to 2. So up to our modeled data, the layer wise assembly will take the parts, and the G code will be plotted. Based on that, based on that, the G code will be generated, and this is in turn will be saved as a DOS STF file. The next one is printing. The last stage in our the last previous stage is printing process. After the layered assembly is completed, we are going to perform that in terms of a 3D printer. So there are so many types of 3D printer. All are having the same cycles. There is no any deviation. All are having the same cycles. So in this 3D printing process, whatever we have done in our layer-wise assembly will be practically done by means of a 3D printer. Whatever we have simulated in our layer-wise assembly software, it is practically we can able to overlook that the printing is being done. So in order to perform that task, we will be taking that layer-wise assembled structure and it will be taken to printing software, and we will be easily getting that object. The last process is post processing. Post processing is removal of excessive raft beads, supports, and so on. So it will be look familiar and it will be looking in terms of your model designed object. So designed object will be easily obtained. So the next content from our 3D printer is what are the types of 3D printers. So we are having, as of now, we are having these few six types of seven types of 3D printers. I have mentioned only six. First type is FDM, fused deposition modeling. Second type is stereolithography. Third type is selective laser sintering. Fourth type is digital light processing. Fifth type is multi-jet fusion. And the last type is direct method light sintering. So total seven types. Electron beam manufacturing has not have added because it is one of the traditional, very oldest method. So I have removed it from the content because we are going for newest approach. That's why. The first one is FDM. I have now I'm going to elaborate the 3D printers. So first one is SLAs, stereolithography. This is one of the oldest type. So this what we are going to do is we are going to pour a resin. That resin will be in terms of a the resin will be poured in a tank. The tank is a transparent layer, and the bed will be completely immersed on the resin. The bed will be completely immersed on the resin, and UV light or UV laser will be passed under the tank. It will pass through the transparent layer and it will project it on the platform. So what we will get is the first layer will get solidified, and then the bed will move out towards upper layer, or the next layer will be created based on the light intensity, and the next layer and the next layer, subsequent layers will be created based on the light intensity. This is one of the oldest method. If now have a look at this diagram I have given. First one is this is only used for creating a polymer. We are going for a polymer. When a UV light is passing over to the polymer, then what will happen is the polymer will get solidified because of the UV laser. And but, whenever that light is getting processed over to the bed, that particular region will get completely solidified. How the particular region will be having a UV intensity, that is because of the G code tooling procedure, which already informed it in the initial slides. Now, this by this method, we will get a stage by stage solidification process. The next one is SLS, selective laser sintering. In this process, a laser is completely sintered and it is completely made to powdered bed. In that process, that the powder material will get completely melted, and the melted metal will in turn create a pattern so that the first layer will be created. This is already available in our stage statement. I mean, in our college premises. So when a laser is directly passed over to a powder, then the powder will get solidified. The selectively the laser is getting positioned, and that particular position will get solidified. That particular position will be in turn will be first layer. Then what will happen is the bed will move downwards. Then the powder will again moves in terms of a roller, this roller. So this roller, what will do is it will completely roll over and make our powder towards the entire bed. And again our LED is passed over, and the process is getting repeated until our 3D object is completed. This is one of the easiest process, and we will get an easy solution and accurate solution in this SLS. The next step is DLP, digital light processing. This is one of the very cheapest. It is already available in plenty. So every medium scale industry has this DLP, digital light processing. Here we will be using a photopolymer resin, and a normal UV intensity lamp is sufficient to create a 3D object. Normal UV intensity, like a mobile display. That a normal display is directly moved to a mirror. That mirror will in turn catch by a lens, and that lens will be giving its radiation towards the transparent LED, transparent tank, and the transparent tank which will in turn solidify the resin based on the size and the shape of the first layer. Wherever necessary, that layer will be completely solidified. Then the bed will be moved towards bottom to top. The bed will be moved towards upward direction, and the next layer will be completely we will have a structure, solid structure. The next one is MJF, multi-jet fusion. In this multi-jet fusion, this is used in industrial application, multi-jet fusion. Here what we'll do is we use a powder, and then we'll apply the same reagent like fusing agent, maybe a resin. So that resin in term at specific area it will completely pour, and then UV is getting exposed. When the UV is being exposed, that particular resin and powder area will get completely strengthened, and we will have a first layer metal solidified object. So the next layer, the platform will get downward direction, will get lowered. The next powder is being injected. Again, the fusion will be placed over the particular areas which we are necessary, and UV will be passed. Again, the solid region will be created. So this is very complex part, and it is only used for industrial application. Then this can be used only for thermoplastic, powder thermoplastic. FDM is one of the oldest technique. FDM, fused deposition molding. There we'll have a filament. That filament is taken to extruded head. That extruded head will heat the filament and melt and pour that melted filament in our platform wherever necessary, based on the layer which we have decided as a G code, advanced G code. So that G code will in turn let the tool path to move the fused filament in that particular direction, and we will get an extruded object. So this is how the fused deposition modeling will be helpful for our particular application. The next one is DMLS, direct metal laser sintering. This is same as SLA, selective laser sintering, and DMLS are having a same concept, but what the only difference is, in SLS we will be using only plastic as a powder. The powder will be in terms of a thermoplastic, but in here DMLS we will be using a metal powder like nickel, zinc, like that. We will be using a metal powder, and the same laser will be in contact with the powder, and it will tend to melt that particular portion, and we will get a first layer, second layer, and third layer. So that particular layers will be completed, completely solidified, and we will get the successive layers. So this is the diagrammatic representation for DMLS. So laser will be applied to that particular region, and instead of powdered plastic, here metal powder has been used. It will be rolled over to the bed. LED laser will be completely passed on that particular bed, and it will create the and solidify, and it will create a first layer, second layer, and so on. And the piston will be moving in downward direction so that the next layer will get processed. And moving on to the next one is what are the material we are going to be using in our 3D printer. So these are the common basic materials we are using for all the applications, any fabricated objects or any individual objects, like ABS. We, these are easily available, so that's why I have made this in the list. Easily available: ABS, PLA, ASA, nylon, TPU, PVA, and PC. So these are easily available in our practical application shop. So nearby vendors, they are having a very good number, so it is easily available. And the types of materials are like this materials are these ABS, PLA, nylon, PVC, PVA, and PC are available in terms of filament. Second one is this is resin. So this is available in terms of filament as well as resin. So in terms of filament, in terms of resin, and in terms of powder also we will have. So every material which I have prescribed will be available in terms of all the three components. So we can able to model in all the 6 category printout. So this printer can easily access the ABS in terms of filament, resin, as well as powder, and it will manufacture the same object, and the time and cost will be varied based on the printer. The next one is slicing software. What are the slicing softwares available in our college premises, and what are the best slicing softwares I have ordered? First one is Cura. This is one of the best slicing software and easily accessible slicing software. Cura. The next one is Blender and Repeater Host. This is Repeater Host is one of my favorite. This can be used for this is like in my own language. This is universal software. Repeater Host. I can able to use this in more than 3 more than 3D printers. Repeater Host. And using Repeater Host, I can able to create small models, not complex model, very easy model. So Repeater Host is what I prefer to use. The next one is Chittubox. Chittubox is LUO software. Some 3D printers will specifically provide Chittubox. Only then, only Chittubox can able to access that printer. So there is no other go. So Chittubox is another software where specific types of 3D printers can be able to understand. So, so these are the important slicing software I have given, and this is for your information. The next one is 3D printer consideration. So, what are the how to create a 3D printer? What are the considerations? What are the factors to be considered when to print a 3D printer? So first one is budget. If you have a budget, then we can go for 3D printer. Then next one is mechanical requirement and material selection. If we are having a specific individual or some new type of material which is not available in market, then we can go for 3D printing material. Then geometry. If we need to change the size, if we need to change the precision or tolerance, then we can go for specific. If it is not available in nature, or if the product needs to be changed based on specific tolerance, then we can go for 3D printing or geometry. The next and the last one is development. Here in the development process, if we have any new ideas which will be So we don't need a traditional machining process to create that object. So in that purpose, we'll be using development. And coming to the advantages will be why we are using 3D printer. What are the advantages of this 3D printers are ability to customize the product. Like we can customize on our own concept. We can customize any place itself. Only requirement is like our ideological concept. That's all. So we can customize at any tangible points. And the second one is rapid prototyping, rapid production of prototypes. We can rapidly create any prototype, from building a construction to building a car model or medical application, biomedical prosthetic arm, anything we can able to create at a instant. So we can give a very speed productive process for that for this rapid prototyping application. The next one is low cost production. Only 3D printer is essential for creating a production. So like we can have a very, I mean, a small scale industry can easily find a solution for creating a part model. A model can be created by means of a 3D printer. So a small scale industry can able to find the solution, or they can able to give you the data. The next one is no cost, no storage cost. There is no need of any storage cost, no huge manufacturing space. There is no huge allotment space, and there is no need of any skill delays. And there is no need for that. Only is there is it is a machine itself, like simple, and it is having a very simple size, compact size. There is no need for any storage cost. And quick availability of parts. The parts are available in nature, so we can easily change and fabricate our objects. The disadvantages like intellectual property issue. We can face there is no intellectual property. We couldn't be able to find that solution, but in future we will find that. And unchecked production of dangerous spots. For danger sharp corners, it will never check for any solution. It will directly do its operation, and if the product is getting damaged, it will damage the 3D printer as well. If the product is getting stuck on the adhesion, it will damage the 3D printer as well. So limitation and size is like based on the 3D printer bed, the object will be we will create the object. If the size is 100 cross 100, the object size will be less than 100 cross 100 cross 100. More than that, we couldn't be able to do. We need to go for another 3D printer based on the size of the bed. Limitations of raw material. If we are going for raw material, like if there is some if the customer is requiring giving a permission for asking for a new material, then there is no possibility for having a new material in our 3D printer. Why? Because we need to check our extrusion heat, and UV light intensity, and laser sintering capacity. So all the things we need to take in mind, and then only we can able to create the raw material. The last one is cost of the printer. The cost of the printer is comparatively high than the normal traditional machine. Normal machines, it will be manual. This is completely automated. That is the reason. Applications. Those applications are mainly, this is completely used in industrial application and domestic application, which I have given below. So have given few applications of this in our prosthetic jaw, and medical applications, and construction business, construction application, and small scale prototypes, and rendering objects. So first one is application I'm going to detail. First one is industrial design. In terms of component, small components, or maybe drones, we can able to use the 3D printer. Next one is automobile and aviation. Automobile sector is completely using nowadays the automobile industry is completely relying on 3D printer. So 3D printer plays a vital role in automobiles and aviation. The next one is architecture. So architectural designs like building a prototype or any architectural designs, we will be using 3D printers. Food industries like face molding or any name shapes or any complex shapes. In order to create that, we are in need of a 3D printer. Instead of filament, we will be using this chocolate as a material. One is medical application. Medical application, it is completely used in medical application. Biomedical application, the 3D printers are playing a vital part because of its tolerance and precision. So, since it is highly precision, then every medical expertise will be satisfied in our products. The next one is artificial intelligence in prosthetic hands or any prosthetic objects. Suddenly, if you are in need of a prosthetic hand or leg, then we can create it on our own by means of a simple 3D printer. If we have any damaged parts, then we can create a damaged part by a simple 3D printer itself. There is no need to search in any search for a long time. There is no other goal. So simply we can able to create it in our 3D printer itself. So conclusion is 3D printer technology could be a revolutionary idea, and it can reshape the world in such a way that the way which we have present the 3D, the way which we have present the subtractive manufacturing is comparatively reduce the wastage. So I'm completely suggesting that it is significantly changing the improvised way to manufacturing the parts and produce a very good marketing worldwide level. And if the last industrial revolution, what is a mass production, it is not it is 3D printer is not compatible for mass production. There is no possibility for mass production. But if there is any possibility for mass production, then 3D printer will be in the manufacturing will be coming back to the circle or coming back to the era to make the process completed. So thank you so much.